Chapter 9: Gut Flora, the key to successful immunotherapy.
When I hear of patients who had failed traditional immunotherapy, one of the first questions I ask myself is, did they have the right bacterial flora in their intestinal system? Were they eating a high-fiber diet and taking the appropriate pre- and probiotics that they needed for their gut to enhance their immune system? Were they even aware of the connection between gut flora and the immune system? Chances are, they weren't. I have to admit that when I first realized that the intestinal flora played a critical role in the function of immunotherapy, I was a bit shocked. Of course, I have known for years that many integrative doctors recommended probiotics, which are bacteria and yeast that aid in the digestive process. I also knew that the gut is a major part of the immune system. But I hadn't appreciated the role of intestinal flora until the publication of 2 key studies showing that the appropriate bacteria in the intestines are critical for the function of today's current immune checkpoint inhibitors. Until then, I felt that these new immunotherapy drugs were so powerful that they stood on their own. I now know that intestinal bacteria is so crucial to effective immunotherapy that it can mean the difference between treatment success and failure. To understand why, let's examine the evolution of our digestive systems. As our species has evolved, our guts have grown smaller. That is because early humans survived by eating a plant-based diet, which required a longer period and more calories to digest. Meat was scarce, and with no way to store it, when it was available, it spoiled rapidly, so not much meat was consumed. Human culture adapted to this diet by learning how to store foods that would otherwise spoil. Fermentation was one of the earliest forms of food storage and appeared in diverse cultures throughout the world in the form of beer, wine, vinegars, and curdled milk products, such as cheese, which contain live molds, and yogurts, which contain living enzymes. Almost all cultures have some form of fermented vegetables, whether kimchi, sauerkraut, or other pickled vegetables. These foods all contained a rich biodiversity of living yeast, bacteria, and enzymes that were consumed and thrived in the gut and helped protect humans from disease. In other words, early humans learned to prepare and store foods in a manner that maintained a complex and diverse microbiology in their intestinal systems. As we migrated northward, however, the cold environment limited plant production, but it enabled us to store and consume more meat. As our diets and environment changed, so did our bodies. The long gut necessary to digest a raw, plant-based diet was less necessary. As we ate more meat and cooked our foods, our guts grew smaller and more efficient in digestion. Shifting to a meat-based diet had its advantages. With less energy necessary to digest raw plant material, our brains developed more rapidly, but it also came with a major disadvantage. The biodiversity of our gut bacteria diminished, a process that has continued with changing technologies that have revolutionized our diets. In our efforts to preserve food for longer storage and to kill harmful organisms present in foods, we have indiscriminately killed almost all of the microorganisms present in our food. Preservation is now more likely to kill the healthy bacteria our bodies need, rather than maintain them. Pasteurization has done an amazing job of protecting us from foodborne diseases, but it has done so at the cost of killing the healthy bacteria along with the unhealthy organisms. Few foods we eat today contain the complex microbiology we once digested regularly. Our guts remain a critical defense system against disease, but the modern human gut has been weakened by our dietary and lifestyle changes. One such change has been the widespread use of antibiotics. Yet another example of how saving lives has come at a cost of human health. Let me explain. When Louis Pasteur and Robert Koch introduced an early form of antibiotics in the late 19th century to treat Bacillus anthracis, bacteria present in livestock and humans, and from which the deadly pathogen anthrax was developed, it revolutionized medicine. The use of antibiotics became widespread in the mid-20th century and continued to be viewed as a miraculous drug because they do save lives. But because antibiotics attack living bacteria, those bacteria that are resistant to antibiotics thrive over time through the process of natural selection. The result is that new forms of antibiotics must be continually developed in order to outwit the harmful bacteria, all the while other bacteria, many of which are healthy and essential to our immune system, are destroyed. Added to this antibiotics resistance is the contemporary practice of adding low doses of antibiotics to animal feed to ward off disease, antibiotics we digest in our meat-based diets. The result of all these dietary and food production changes is that our guts have changed, and not for the better. The modern guts of most people who subsist on a meat-based diet high in processed and refined foods have lost the diversity of microorganisms that our immune systems depend on to do their job. Now let's turn to the role of antibiotics in cancer treatment. It is very common for cancer patients to receive antibiotic therapy sometimes during their treatment since their immune system has been jeopardized and they develop various infections. In addition, some antibiotics are known to have an anti-cancer properties in their own right. Though antibiotics are often necessary for treating infections, it is extremely important for them to be used appropriately. Studies are now indicating that treatments with antibiotics up to 1 month prior starting immunotherapy may have negative effect. Pinato et al. Presented at the ASCO-SITC 2019 conference a poster of multi-center trial looking at antibiotic use with PD-1, PD-L1 inhibitors. They showed that median survival for the entire group was 2 months of those that received antibiotics within 1 month of starting immunotherapy versus 26 months with no prior antibiotic exposure. It is important to note that they observed no difference in survival if the antibiotics were started after immunotherapy had been initiated. That may mean that having the microbiome, the ecosystem of bacteria and yeast in the gut, intact from the starting dose may be protective even if the microbiome is negatively altered after. Unfortunately, standard probiotics do not offer any protection and even slowed the recovery of the microbiome after antibiotic therapy. In a 2015 study by Zitvogel, published in Science, she showed changing the bacteria of the gut microbiome could impact the success of immunotherapy in mice. In 2017, further work that she published in Science looked at human cases and how the use of antibiotics was linked with lower success and shorter lifespans. This is a very hot topic of study in cancer immunotherapy. It is clear that the bacteria in the gut play an important role in the response to immunotherapy. Some estimate, including myself, that many patients are missing out due to not having the appropriate bacteria, and if this were addressed, the success rate may double. We could not put a good estimate on this right now, and as therapies improve, it will probably be even more critical. I would estimate that having the correct bacteria in the gut, even without immunotherapy, may be able to prevent cancer, which probably could save the lives of tens, if not over 100,000 lives a year. That is something to take notice about. Now I need to explain what you can do to enhance your chances of an optimized microbiome. What are the key bacteria identified to enhance immunotherapy? In a study published in November 5, 2015, edition of Science, Savan et al. Demonstrated that Bifidobacterium were essential for the function of anti-tumoral immunity involving anti-PD-1, PD-L1 immune checkpoint inhibitors. This is very important for the currently popular drugs Opdivo and Keytruda. More than just Bifidobacterium in general, it was indicated that the specific species were Bifidobacterium longum and Bifidobacterium breve. What this means is that Bifidobacterium, especially those containing the longum and breve species, should be supplemented in any cancer patient's therapy. How do you do that? Bifidobacterium can be purchased over the counter, but it is essential to buy it refrigerated. In any other form, it may not be as potent as more of the bacteria will die. It can also be found in yogurts made with live cultures, fermented foods such as kimchi and sauerkraut, though many of these fermented foods have been pasteurized, so only homemade or artisanal products are likely to contain living bifidobacterium, some miso, tempeh, and umeboshi, a Japanese fermented plum. Whatever form you find it in, always consult with your physician about how to incorporate bifidobacterium into your diet, but do include a refrigerated capsule or powder form a few times a week to ensure you are consuming the correct amount prescribed by your doctor and that it includes significant quantities of Bifidobacterium longum and Breve. In addition, you need to make sure that these bacteria are fed properly. Certain diets will affect the composition of the gut flora, particularly the standard high-fat American diet, which I suggest you avoid. To ensure that the good bacteria are fed properly, make sure to use a daily prebiotic that contains oligofructose or FOS. Studies have shown that the increased diversity of the bacteria in the microbiome was another indicator of improved responses to immunotherapy. This was discussed in an article by Gopalakrishnan, Science, January 5, 2018. In general, work published by Dr. Jennifer Wargo from MD Anderson has pointed mostly at a high-fiber diet from increasing diversity. The types of fat will also affect the microbiome. Many et al. Published an article in Scientific Reports, September 2017, showing that omega-3 fatty acids are important for microbiome diversity in addition to a high-fiber diet. There have been several recent studies further investigating gut bacteria, microbiome, and the overall associated treatment success with immunotherapy. Studies published in the November 2017 issue of Science by Zitvogel, Rauti et al. Demonstrated that the gut bacteria Akkermansia muciniphila was the key to turning mice that did not respond to immunotherapy into ones that did. These same bacteria have an important topic in the past when it comes to obesity, as a higher amount within the gut is found more often in thinner people as compared to the ones that are obese. However, this is a separate issue when it comes to cancer. It seems that this bacteria is involved in eating mucus in the gut. Though an increase of Akkermansia muciniphila results in actual increased mucus along the intestinal lining, it seems to increase the interaction of beneficial bacteria with the intestinal wall and at the same time reduce issues of bacteria permeability of the intestinal wall known as leaky gut, which increases inflammation in the body from bacteria substances crossing the bowel wall into the bloodstream. Since this bacterium, Akkermansia muciniphila, is so important, how do you make sure that you have enough? Well, that is the complicated part. It does not exist currently in probiotics. However, certain prebiotics that I mentioned containing fructooligosaccharides were shown to increase this beneficial bacteria. In an article published by Dr. Kekwon Jo, Wayne State University in Journal of Functioning Foods, March 2017, titled Strategies to Promote Abundance of Akkermansia muciniphila and Emerging Probiotics in the Gut, Evidence from Dietary Intervention Studies, he outlines diet and supplement changes. Again, a high-fat, typical American diet is very bad and reduces the number of these bacteria. In his article, he cites studies of polyphenols and specifically points to cranberry extract as being able to increase fecal A. muciniphila. Also, very interesting is that Dr. Zhao also references studies to metformin to increase A. muciniphila, which is commonly incorporated in cancer treatments. The anti-cancer effects of metformin have mostly been attributed to inhibition of the mTOR pathway and not for glucose control as many would think. It may be that the anti-cancer action of metformin are more firmly rooted in the effect on the microbiome. This is becoming a common theme with so many substances that have demonstrated anti-cancer properties. We are now discovering their effects on the microbiome may be their key action. One other interesting aspect in the article by Dr. Joe mentions studies supporting rhubarb extract, which has been reported to have anti-cancer properties and also shows positive benefits on the microbiome, including increasing eosinophils. Rhubarb extract may be another supplement for cancer patients to put on their essential list. For many years, there has been a group of integrative doctors promoting the use of pancreatic enzymes for the treatment of cancer. Needless to say, this has been met with much controversy. Much of this is related to an embryologist named Dr. John Beard, whose work dates back to the early 1900s. It seems that the work of Dr. Beard was forgotten until the late Dr. Nicholas Gonzalez resurrected it in the 1980s. Though there may be different theories of how pancreatic enzymes may have anti-cancer properties, one very interesting aspect is in the article published by Nishijima et al. In Biochemical and Biophysical Research Communications, October 2017.